Okay, today we're going to go ahead and learn about some inverse functions and their attributes here, okay? And so we're going to basically hone in on the graphical perspective of inverse functions and then take a look at what goes on with them, okay? And so the three things that we're going to discover are going to be about inverse functions is that the x and y values switch, the domain and ranges switch, and the graphs reflect about the y equals x line. And the y equals x line is just a diagonal line that streaks through a graph right here, okay? And so we'll come back to that in a moment. We're also going to take a look at one-to-one functions, okay? And one-to-one functions are going to be something in which where when you, quote, do an inverse of a function, that is going to be a function as well, okay? And we'll see what that means in a moment. And one way that we can test for if something graphically is a function or not is a vertical line test. And so if it is a function, then we have all these vertical lines. No matter where I draw a vertical line on the given graph, it's going to go ahead, and when I say the given graph, it's this guy right here. It's just going to hit once, okay? Whereas if I were given this graph right here, and I drew a vertical line through there, it would hit twice, well, actually 3 times, right? So it would hit more than once, basically. And that would denote that that is not going to be a function, okay? And so let's go ahead and take a look at our first example, building a function and seeing what lies in wait for us. Okay, so we have a simple parabola, and what I've done, I want to start with the original points right here, okay? And we're just plugging the x's in and getting y's out, okay? So I'm going to fill that in real quick. Okay, so I filled them on in, and it is going to look like the parabola there on the left, okay? Now, to build a graphical inverse, okay, and it might go ahead and be an inverse, or it might be a relation, and I'm going to explain that in a moment, is that we want to use this property, okay, and the property that the x and y values switch. So to do that, what I'm going to do is that these are the x values and these are the y values, and what I'm going to do is that I'm going to switch them over on the right hand side to make inverse points. So I'd have 9, -3, okay? So that means that I'm putting the x's and y's flip-flopped around, 4, -2, 1, -1, and etc. Okay, so I just finished that on up. So now I have a set of inverse points, and what I'm going to do is that I'm going to start graphing those out. So I would have, let's start at the top here, I'd have 9, -3, okay, and 4, -2, 1, -1, 0, 0, 1, 1, and then I would have 4, 2, and then 9, 3, okay? And I can trace the parabola like this. Okay, so there is the not-so-great parabola, if you will, that's over on its side. So what I want to do is that the domain and range, notice that this has happened. So the domain from a regular parabola was going to go ahead and stretch infinitely, or I should say the original parabola is going to stretch infinitely from left to right, and it's going to start at 0 and go all the way up for the range. Whereas if I were to look at the inverse, the range now is going to stretch infinitely from left to right, and the domain is going to go ahead and go from 0 to infinity. And that's a really important part as we move through our mathematical progressions here, okay? So what we do want to do is that we want to see if it's going to be one-to-one, okay? So that means is the purple parabola that is over on its side, is that a function as well? If it's not a function, then these are not one-to-ones, okay? So that means is that the graphs are they going to be inverses, one-to-one functions, or are they going to go ahead and just be a relation, which means that the graph still exists, but it's not a function. So the way that we do that is that we draw a vertical line, and we see that that thing hits twice. And so that means is that the graphs are not one-to-one, okay? So that means that one of them are not functions, okay? And so that means is that they are a relation, okay? So let's look at the second example going on to a cubic function here. Oh, before we move on, one thing that I did forget to mention is I want to point out is that we have this part, which is really important as well, which is going to reflect over the y equals x-axis. So that means is that this line right here, okay, and I'm going to get rid of the vertical line test that we just did here, and I'm going to draw, and again, it's just a diagonal line that is at like 1, 1, 2, 2, 3, 3, 0, 0, negative 1, negative 1, negative 2, etc. Okay, and it looks like it's going to reflect over that. And when I say reflect, it's kind of as if that were a fold in a paper, that it would go fold over onto this function right there and back and forth. Okay, so that means that reflection is going to take place over the y equals x line. Okay, so let's look at the second example here. Okay, so we have our cubic function, and what I'm going to do is the same thing. I'm going to get the x and y's all loaded up. Okay, and for the inverse points, we are going to go ahead and do the same thing. We are going to switch the x and y's, okay? And so that is going to be a -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So when I plot these all out, okay, so that's going to be a -8, -2, -1, -1, 0, 0, 1, 1, and then finally this guy right here. And if I connect all the dots nicely, we have a graph that looks like this. Okay, so let's take a look. Are these two guys one-to-ones? Okay, that means is that is the function, the inverse function I just made, okay, the graph, going to pass the vertical line test? And it does. No matter where I go on this graph, you can see that it only hits once. All right, so therefore that means is that the graphs are 1-to-1 inverses. Okay, so that basically means is that they are, the graph of the original is a function, and the graph of the inverse is a function as well. And then just for good measure, we can take a look at this y equals x. Just going through here, trying to make it as straight line as possible. Okay, and you can see again that they reflect over that. Like this piece would go ahead and reflect over here, and this piece would reflect over there. Okay, so that said, there are 2 examples, and then I'm going to leave the next 3 for you, and then I will reveal the answers in a PDF on Plots Math, and take any questions as they come up. So thanks for watching, and see you next time.